Well, today our discussion will be from the various concepts of the elasticity, like what is elasticity, how it is distinguished from plasticity, uh, how we explain about stress, strain, the Hooke's law, the Young's modulus, the bulk modulus of elasticity, and the modulus of rigidity. So before starting with the main concepts, I will just brief it. Elasticity is the property of material due to which it comes back to its original position when the applied forces are removed. And similarly, when we remove the applied forces and the body does not come back to its original position, the body is said to be plastic. So plasticity means that there is deformation, or plasticity means that even when we remove the applied forces, the body does not come back to its original position. Now, if we make the comparison of steel and rubber or glass and rubber, we find that if we apply same force to both steel and rubber, the rubber will be stressed more and it will take more time to come back to its original position. So it will be less elastic. But if we consider steel and if the same force is applied, we find that deformation is very low. And the moment we remove the force, it immediately comes back to its original position. So steel is more elastic as compared to, that is, rubber. Another thing which is important, that's about the stress and strain. When we use the terminology stress, stress means force per unit area, and the force is normal to the surface, and its unit will be Newton per meter square or dyne per centimeter square. Then we come towards the strain. It is basically a ratio of the change in shape to the original shape, and this change in shape to the original shape can be lengthwise, the area-wise, or the volume-wise in any of the three dimensions, and we find that there is no unit for the strain. So strain will be change in shape over original shape. If it is longitudinal strain, that's small l over capital L. Similarly, we can explain it for area and for, that is, volume. After that, we come towards, that is, the Hooke's law, which states that stress is proportional to strain under the elastic limits. That is up to the time the body is not fully deformed. And similarly, Hooke's law states that stress-strain ratio will remain constant. And in Young's modulus of elasticity, again, it is an extension to the Hooke's law. And there we say that Young's modulus Y is stress over strain. Stress can be taken as force over area, and strain can be taken as small l over capital L. And when we speak force, we are referring to weight, that is mg. So area will be pi r square, or r is the radius, and we can also explain it like pi d square by 4. So these are the facts we have to use, and now we come towards the main concept of elasticity. So in the main concept, when a force is applied upon a body, then there is change either in size or shape or both. When we speak size, we are referring to either lengthwise, area-wise, or volume-wise. This force is called the deforming force. So it is essential that in order to deform the body, some force is always applied, and that force is called the deforming force. Now in the given figure, we find there are three diagrams here. On the left, extreme left, it is indicated tension. That is, an original wire is indicated. Its original length is L0. And when downward force, that is, some weight is suspended, we find that the wire is slightly stretched. So the green portion, the dotted portion, is indicating that there is slight displacement, and delta L is the change in length. So it means that when the downward force is applied, there is slight change in the length. Then in the second figure, what we find, originally forces is applied, that is when both forces at the top and bottom are same and in the opposite direction, we are finding that again there is compression, that is wire is slightly compressed. So it means that again change in shape takes place, and in the third figure that is called shearing, and in that case we will apply some force towards the left side wall, and we'll find it is slightly displaced by delta L. So this displacement is lengthwise and it will be delta L. So original length is L naught, but we find that there is slight change in length and that is delta L. So in all three cases, it is indicated that the applied force causes deformation and therefore the forces applied are called the deforming forces. The property of the material of a body by virtue of which the body opposes the change in shape or the size produced by deforming force or the external force and recovers its original state as soon as the deforming force is removed is called elasticity. So we can brief it like this, that elasticity is the property of material due to which it comes back to its original position when the applied forces are removed. Basically, when we apply the force, displacement takes place and we find that restoring force start operating towards the mean position. And now the next one is those bodies which completely recover their original state on removing the deforming force are called perfectly elastic bodies such as quartz. However, for increasing the knowledge, we can say that there is not 100% perfectly elastic body. So we are just very close to that. It can be 99.9999%, but it cannot be exactly perfectly elastic. But being the variation is very small, so we assume theoretically that we are taking perfectly elastic body and that will be quartz. And that's why quartz is sometimes used in the watch as a crystal for adjusting the time, which we normally observe on the dial. Those bodies which do not recover their original state when deforming force is removed but retain their modified form are called the plastic or perfectly plastic, such as a piece of wax, wet clay, etc. So just in brief, we can say plasticity is the property due to which body will never come back to its original position when the applied force is removed, and the examples are being given. That is, one is wax and other is clay. We can have many other examples. Moreover, perfectly plastic body is not possible. However, we know that plasticity, elasticity are just very close to 100%. No substance in nature is perfectly elastic, as I have explained earlier. Up to a certain limit, a force of a force, the substance or bodies are considered to be perfectly elastic. For example, if we consider a wire and we apply force, we will find that it is going on elongated, and up to a certain extent it will elongate. After that, it will, when we will further apply the force, it will start yielding, the yield point will come, and if we overcome the yield point, and finally it will come the break point. So before break point, the elasticity will be maintained. Now, if there is no relative displacement between the particles on applying an external force upon the body is called the rigid body. So what's basically a rigid body? Now, we will assume that in a solid body there are many number of particles, and when external force is applied, and if the particles are not displaced from their mean position or there is no relative displacement, the body is supposed to be a rigid body.